All right, welcome to lesson 6.1 on algebraic expressions. This is part 1. And I'd like to review the parts of an algebraic expression. We have a coefficient, a variable, and a constant. And here's my example of a simple algebraic expression. 3 is the coefficient, it's the number multiplied by the variable. And x is our variable. That represents a number, but we're not going to be solving for that variable quite yet. That happens in equations, and we're working on expressions. And by the way, the difference between an equation and an expression, we have our expression there, but maybe an equation would be 3x plus 4 equals 12. And in this, we would then solve for x and find out what the value of that variable is. But we're not doing that here. We are simply simplifying expressions. And 4 is our constant, it doesn't have a variable attached to it. So we are going to be working on adding and subtracting expressions. And we do this to simplify the expression. Now, we can use a variety of strategies, but in this example, I'll show you how we're going to organize these expressions. So Jill and Kyle get paid for a project. Jill is paid a project fee of 25 bucks and $10 per hour. Kyle is paid a project fee of 18 bucks and 14 bucks per hour. So we're going to write some expressions to describe how much money they're going to get paid. Jill, here's that $25 for the project fee and $10 per hour. So it's the hourly rate times the number of hours she's working. And Kyle gets $18 and $18 for the project fee and $14 per hour. Now we can combine all this stuff. We have Jill. I will erase that part. So Jill is right here, and Kyle is here. So we put the two things together. We're combining their pay, and then they're saying here we're going to use the commutative property, which really just says you can switch the order of things when you're adding and you still get the same answer. So the publisher decided to put the project fees together and the hourly rates together as well. And so the 43 represents the total in fees, and the 24 represents the total per hour fee. So there we go. The company pays 43 plus 24 times the number of hours being worked to hire both Jill and Kyle. And what can you read directly from this expression here that you don't get from this? Well, you can see that 43 is the total for fees and 24 is the total for the hourly wages. And you don't get that from the long expression. And this is the core of what we're looking at here. We are simplifying algebraic expressions, which means we're taking this long expression here and we're turning it into a small one here, which is easier to read. So what do you get from this? You get the total amount the company pays in fees and per hour. It's broken out, easier to see. Okay, so what we're trying to do here in this number 2 is we're combining our like terms. We're simplifying the expression. Really two ways of saying the same thing. And we're going to combine our variable terms, the 3x and 7x. We can add the coefficients together. 3 plus 7, that's 10. Okay, that's easy. And then we also have to combine our constants. We're adding a half and we're subtracting 4 1/2. So when I put that together, I have -4 or -4. Because 1/2 minus 4 1/2 equals -4. And I get this, 10x minus 4. All right, the next one, I have my variable terms I'm going to put those two together. I can't put the x term together with the constants. The variables have to match up. The type of number has to match up. So we have negative 0.25 and, oh yeah, look at this. That right there, that's a big deal right there. I have to rewrite this here. So let me rewrite this. I'll do it in black. So we have negative 0.25x minus 3. And then this minus, I have to subtract everything after that. So that means I have to subtract 1.5x and I have to subtract 1.4. So in a way, this right here distributes to each item after it, not before it. And I will now combine that and that. Well, they're both negative. I know that this one says minus, but minus and negative, they both count for the same thing. So negative 0.20, I have to have 0.25 and 1.5. I have to add them up. I'm adding them, but in the end, it's going to be negative 1.75 because I'm adding two negatives together. And the same thing's happening here. Minus 3 and minus 1.4, that also counts as negative 3 and negative 1.4. And they're the same sign. So 3 plus, oops, 3 plus, okay, that didn't work so well. There we go. And 1.4, I add them up. That's 4.4, but it counts as a negative 4.4. Oh, and I can't forget this. I almost forgot that as a variable term. So there we go. All right. So we're going to move on to the distributive property. And you could use the distributive property if you remember that. That is distributing the 3 to the x and the 3 to the 5. That's 3 times x and 3 times 5, which is right here. And 3 times x is written as 3x, and 3 times 5 is 15. So we're going to use that in this problem. So we have writing the problem down, and we would distribute the negative 3. So notice here, negative 3 times 7 is negative 21. And negative 3 times positive 8 is negative 24. And now the publisher decided to say, okay, if you have this, minus 21x is the same thing as adding a negative 21, and minus 24 is the same thing as adding a negative 24. And then they use the commutative property to switch things around. You can move this over here, and then now you see you have 5 plus negative 24, which is negative 19, and plus negative 21. And usually, I mean, this would be fine. Yeah, I'll just go with that. But, well, I'll just say that many times in algebra, your teacher in algebra will say, well, we want negative 21x minus 19. We want the variable term coming first in our answer. But both will work. What I usually do is I'll just jump in and say, well, negative 3 times 7, that's negative 21. Negative 3 times 8 is negative 24. Oh, I almost forgot the x. And I have 5. And then I'll just look at, well, here's my variable term, negative 21x, and 5. And then I'll look at 5 minus 24. 5 minus 24 is negative 19. And I'll just write my answer like that. All right, so I'm going to simplify each of these expressions. And the first thing I'm going to do is I'm going to look here, and I have to distribute the negative 3. I see that negative 3 is being multiplied by everything inside the parentheses. Better do that. So negative 3 times x, that's negative 3x. And negative 3 times negative 2 is positive 6. I'll write down the minus x and the 5x. Now what I'm going to do is I'm going to look at all my x terms and put them all together, which is to combine them. 5 minus 3, that's 2x. And minus another x, that counts as 1x. So 2x minus x is 1x. and plus 6. I can't put those two together because the x, there's only one x term. And x is the same thing, 1x is the same thing as just x plus 6. So that would be my answer. The next one here, I'm going to distribute the 0.5 right there, because that 0.5 is being multiplied by everything in the parentheses. Multiplying by 0.5 is the same thing as taking half of it. So half of 12y is 6y, and that's positive times negative, so that's negative or minus 6y. And 0.5 times 7, half of 7 is 3.5, and negative times negative is positive. Now I'll write down the rest here, 8.3 plus 3.4y. I'm going to combine my like terms here, the two y terms. 3.4 minus 6. I have to subtract these two. So I have 6 minus 3.4. And 6, you have to line up your decimals. 6.0. 10 minus 4 is 6, and 5 minus 3 is 2. So that should be 2.6y. And then I have 8.3 plus 3.5. Well, 8.3 plus 3.5, that's 11.8. So that's plus 11.8. And that should be our answer there. And what they did here is we should see that 2.6 is positive, and ooh, I didn't catch that at first. It is definitely negative, because in this here, in this one, 6 is bigger than 3.4. I forgot that part. It's definitely negative. And 11.8 is positive. Okay, great. So what we have is a distribution of 1/3 to each of these. 1/3 times 3/4. Cancel the 3's and you get 1/4. And that's positive 1/4. Because you have negative times negative is positive. Then you have 1/3 times 2/3. 1/3 times 2/3. And that would be 2/9. And negative times negative is positive, so that's positive 2/9a. And then you have 1/3 times 12. 1/3 times 12 over 1, which is 12 over 3, and that is 4. So that's negative times positive, that's negative 4. And then we have also negative 9a at the beginning. And we would combine our like terms. So negative 9 plus 2/9. You need common denominators. And 9 is the same thing as 81 over 9, and that was a negative. So negative 81 plus 2, that is negative 79 over 9. So when I put these two together, I get negative 79 over 9a. And then I have the constants to deal with. So I have 1/4 and minus 4, and I need the, or 4 over 1. I need common denominators again. And this is 1/4 still, and this is going to be what, 16 over 4 is equal to 4 over 1. 1 minus 16 is negative 15 over 4, so that's minus 15 over 4. And that would be our answer for that one. All right, so to simplify these expressions, first, I have an answer here. I kind of jumped to the answer, but we would distribute 0.2 times 3, that is 0.6, and don't forget the b, and then 0.2 times 15, that should be 3. Yeah, because 15 times 0.2, that is 3, 3, and then, oh no, it's 10. 3, I was thinking about that. So that is minus 3c, and then you add 6c, and negative 3 plus 6, that is positive 3. and you have 0.6b. So that's why we got that for a simplified answer. Now for the next one, we have to distribute the 2/3 to each item. 2/3 times 6. Now, when I do this, I see that 3 is a factor of 6 and 9 and 21. So what I do is I do this. I'll look at 3. How many times does 3 go into 6? It goes 3 goes into 6 2 times, and I multiply that by the numerator, 2. So that would be 4e. That's how I could distribute the fraction to a whole number. This one, instead of doing 2 times 9 divided by 3, which you could. I mean, 2 times 9 is 18, and 18 divided by 3 is 6. I tend to look at, well, 3 goes into 9 3 times, and 3 times 2 is 6. And then distribute there. 3 goes into 21. 3 goes into 21 7 times, and 7 times 2 is 14. And that would be minus 14g, and then minus 7f. And I have only 2 terms here that are the same. 6 minus 7 is -1, so it'd be 4e minus 1f minus 14g, and minus 1f is the same thing as minus f, so we could have 4e minus f minus 14g. Let's see what we got here, and there it is. There you go. It's all about simplifying expressions, algebraic expressions.